My name is Lenny Giuliano from Juniper Networks, and I'm going to talk about today TreeDN, which is a CDN architecture optimized for mass audience live streaming. So let me start this talk with three questions to keep in mind as we go through this presentation, and I'm going to kind of address each of these three. First, are we approaching an inflection point for network resources based on what's going on with live streaming? Second question is, if not, will we ever? And if the answer to either of those questions is yes, what should we do about it? So first, let's just look at the numbers for streaming, live or otherwise. When it comes to high def bit rates, it's about 5 megs per stream. 4K is about 8x that. 8K is about double of that. And VR is astronomical. VR, AR, the numbers are all over the map, from 0.5 gigabits per second to 5.2 gigs per second. Now, Akamai, which I believe they're one of the biggest, if not the biggest, CDN provider on the internet. Every year they announce that they've broken a new record for the most amount of traffic sent simultaneously on the internet. The last time I noticed the number was 167 terabits. That was the most traffic they'd ever sent all at once. So just for fun, if we divide 167 by 40 megs, just to see how many 4K simultaneous streams it would take to break that record, the answer is about 4.2 million. And to give you an idea, 4.2 million would correspond to the 117th most popular television show. So that's the predominant method for delivering content today is Unicast, brute force Unicast. If you need to send 10 streams, if you have 10 viewers, you have to send 10 streams. If you have 1,000 viewers, you have to have 1,000 streams. So this brute force Unicast method, can it keep up? It seems to be working just fine right now, to be clear. But the question is, can it last forever? Just to give you some more numbers, the average NFL game, which is American football, has 15 million television viewers. That's an average game, not a marquee matchup, not a playoff game, not the Super Bowl. If all 15 million viewers were watching at 4K at 40 megs, that would be about 600 terabits. So we're talking one game would be 5x what was previously announced as the largest amount of traffic by the largest, one of the largest, if not the largest, CDN providers. And for those of you who, wondering, the latest NFL deal actually includes games that are available exclusively only through streaming. And it goes up from there. The Super Bowl has about 100 million viewers, simultaneous viewers. The 2015 Cricket World Cup had 2 to 3 times that. And the last World Cup in soccer or football, as you call it, had about 500 million simultaneous viewers. Also, the cord cutting evolution probably began, 12, 13 years ago with Netflix and YouTube and Hulu. And it was really all about on demand, watching shows when you want on demand. But the evolution and all the excitement is really about capturing that last bastion of folks who haven't cut the cord and are still paying their cable bills. And that is live linear television. Where you see with companies like YouTube TV and Sling TV and Hulu TV, and it's about going after those last holdouts. And in a word, it's about sports. If you want to ask, does anybody still watch live linear TV? The simple answer is sports. So live linear TV is not dead yet. And in fact, it's actually trending. We live in a fake world, of fake news and deep fakes, a low trust world. Where the typical corporate communications of any large company looks like it was torn straight from the pages of Orwell. So it's a low trust world that we live in, and due to the spontaneous and uneditable nature of live streaming, it's perceived as more authentic and more emotionally engaging than on demand. I mean, that's probably the reason why I'm speaking to you live and not just a 25-minute recorded presentation that, then I appear at the end to give, to answer questions. For some reason, live is just more interesting and emotionally engaging. And marketers have known this for a long time. People spend more time with live videos than on demand. they're more likely to make purchases, and the ROI is much higher. And the COVID pandemic, prior to the pandemic, live streaming was the fastest growing segment of online video. The pandemic has only exploded that for things like e-learning, fitness and wellness classes, conferences like this, worship services, sporting events. These are huge drivers, and the numbers bear this out. The numbers are just astronomical from the beginning of the pandemic onward. I would point out live streaming e-commerce is absolutely explosive. The numbers are just mind-blowing, and it's tough to imagine in China. But this is huge in China. So live linear video is here to stay. It's not going anywhere. The problem is the internet is based on a unicast model that is well suited to pretty much all traffic except multi-destination. This is why Multicast was created more than 2 decades ago to solve this problem. So what went wrong? And I'm going to talk here and focus here on Internet Multicast because Multicast is widely deployed in certain places, in walled gardens for video distribution, for financial networks. Multicast is huge. But on the internet, it never gained the traction that its advocates hoped. So why? Well, let's go back to the beginning. And in the beginning, there's Unicast. And if you have interested receivers, they get a separate data stream for each of these live streams. And you can see very quickly, this gets costly for the source. The source needs a server big enough to push out all of those sources, all those streams to each of those receivers, and needs enough bandwidth to send it to each of them. So along comes Multicast, which allows the network to discover all of the interested receivers, builds a tree just to those interested receivers, and delivers the content such that no one link carries more than one copy of the data stream. But there's an obvious problem with Multicast. First of all, the internet is not a monolithic network. It's a network of networks. Some of them are multicast enabled. Most aren't. So if you have a source on a multicast enabled network and you have a receiver on a unicast only network, the result is unbounded sadness. Sadness on the part of the receiver who can't receive this content. Sadness on the part of the source who has an interested receiver, is able to multicast, but can't deliver that content. This is known as the all or nothing problem. Every link from source to receiver must be multicast enabled in order for multicast to work. What that means is every router and firewall on the internet needs to be running PIM or MLDP or some type of multicast routing protocol. That's a really high bar. So as a result, CDNs came along, and there's different models for CDNs, but just one popular model is you deploy these boxes, these CDN boxes throughout the network, deliver the content to each of them, and then they handle local receivers. It's almost as good as multicast, and it just works. You don't need to turn PIM on every single router and firewall on the internet. So if we compare these 3 delivery mechanisms, Unicast, CDNs, and Multicast, and we look at cost as a function of audience size from the perspective of the content provider, and that's important. Think about this from the perspective of the content provider. For Unicast, it's simple. You have 10 viewers, you got to send 10 streams. You have 1,000 viewers, you have to send 1,000 streams. For CDNs, there is still a per user cost, but the cost is much lower. So the slope of this line is much smaller. But do notice that there is an initial cost, and that's the cost to rack and stack those boxes, power them up, plug them into routers. By comparison, multicast, whether you have 1 viewer or 1 billion viewers, the cost is constant. So the marginal cost for each additional viewer is 0. And again, this is from the perspective of the content provider. That's an important distinction. The important thing to note here is CDNs don't eliminate the brute force unicast problem. They just distribute it. So there's an agency, a satellite agency out there called UMetSat. They basically do atmospheric. They're an atmospheric and meteorological agency in the UK, in the EU, and they are streaming meteorological and atmospheric telemetry data constantly in real time, high bandwidth streams. These are like 150 meg streams, and they're constantly sending those out to research institutions. And they're doing it via multicast. They're doing it in multiple ways, but one of the ways they're doing it is real live interdomain multicast. And they've said that if they were to do the same thing with unicast CDNs, it would cost them an order of magnitude more expensive than doing it with multicast. Just as a technological aside to those big fans of V6 out there, and I'm sure you're out there, the folks who really are strong advocates of V6. I think multicast and V6 are related. I would call them technological cousins, in that any argument for and against V6 kind of applies equally well to Internet Multicast. The folks who say you don't need it, for V6, we've got NAT. Why do we need V6? Same thing goes for multicast. Why do we need multicast when we've got CDNs? On the other side, the advocates would say we absolutely need V6 because we've exhausted V4 addresses. Similarly, multicast advocates would say, duplicated video streams are incredibly inefficient. Both suffer that same all or nothing problem that I mentioned. Both require new protocols or extensions of old ones. Both were born around the same time in the 90s, struggled through adolescence. And while V6 is certainly doing better than its multicast cousin, I'd say they're both still living at home with their parents, who are kind of nervous and concerned. Both require faith in the unseen, in that alone, they do nothing, but they enable bigger things. So what's new? Internet Multicast has been around since the 90s, hasn't gained a whole lot of traction. Why will this time be any different? Let's start with the three problems of multicast, the three biggest problems of multicast. I've talked about the all or nothing problem. The second one is multicast is too complex. Service providers, network operators have been complaining for decades about all the complexity of multicast and getting it working, and all the headaches to configure it, to troubleshoot it, to manage it, to operate it. And the third thing is there's a chicken and egg problem with content and audience, where there's no audience because there's no content, and there's no content because there's no audience. All right, so here's what's new. And there are new developments that address these fundamental issues and kind of take them off the table. So most recently is ASM Deprecation. This is a relatively recent RFC, BCP level RFC, that essentially says, stop doing ASM. And ASM is the traditional model that supports both one-to-many and many-to-many. And just do SSM. It turns out multicast isn't complex. ASM multicast, any source multicast is complex, and more specifically, source discovery, network-based source discovery. If the network is responsible for discovering the sources, that's where all of your complexity lay. So if you just do SSM, you take source discovery out of the hands of the network, put it in the hands of the application layer, you can eliminate about 90+% of the complexity of multicast. You get rid of rendezvous points, MSDP, PIM register messages, NCAP and DCAP, shared trees, tree switchover, all of those things go away. And with SSM, you're left with PIM SSM is about as complex as LDP. And nobody complains that LDP is too complex. This BCP is applied already in Internet 2. And this solves that fundamental, problem number 2, multicast is too complex. The second thing is overlay networking, and specifically automatic multicast tunneling. So when I started in this business in the 90s, tunneling was a suboptimal hack, something to be avoided, something to be eliminated. It turns out if you just rename it from tunneling to overlay networking, all the cool kids are doing it. So it's now fashionable. And it solves the other two problems. One, the all or nothing problem, because we can tunnel over the routers that and firewalls that don't support it. And it also solves that chicken and egg problem by now making the audiences potentially anybody on the internet. So all the pieces are in place, and I'm going to kind of demonstrate what they look like. So what is AMT, automatic multicast tunneling? How does it work? So let's start with a multicast enabled service provider. There aren't many, but they do exist. Think Giant, the research and education network of Europe. And imagine a multicast enabled content provider. Not many, but they do exist. UMetSat is a perfect example. And imagine a multicast enabled local provider. Again, not a lot of them, but they do exist. Most commonly on the RENs, the research and education networks, the regional RENs and the national RENs. So imagine you have multicast stream with a bunch of interested receivers. They will receive it natively the way we all understand multicast to work. But imagine a unicast only network. The other 99-point-something% of the internet is unicast only. So imagine you have an interested receiver who sends an IGMP report to their last hop router, and that last hop router is not running multicast. So now what? Well, if this client, and this client could be a laptop, it could be a smart device, a phone, cell phone, an iPad, whatever, a smart TV. If it has this AMT client, AMT gateway client, which is a thin client, that is able to magically discover the nearest AMT relay, which is a special box that sits at the border of a multicast-enabled network. And it can dynamically discover and build a UDP tunnel to that relay, and then send an IGMP report through that UDP tunnel. The relay, in turn, receives that IGMP report, joins it natively through something like PIM, and takes that native stream and sends it over the UDP tunnel to the gateway. As we have more and more clients interested, they receive separate tunnels. Now we see also the unicast only network finally has a reason to actually turn multicast on. Previously, because of the chicken and egg scenario, why would a unicast only network operator bother with the hassle of turning on multicast when nobody's using it and there's no content out there? Well, if all of a sudden a zillion duplicated unicast streams are going over the network, finally there's a business case and a reason to turn on multicast. And this is the key thing to keep in mind of AMT. It is a stopover. It is a transition point. It is not a destination. It gets you from to go down the path of going native. Now, there's always going to be parts of the infrastructure that are not multicast enabled, and that's AMT. So AMT is always going to have a place in networks, but for the most part, the goal is to get you to the next step, which is native, and to motivate. So let's go back and look at CDNs without multicast and compare CDNs to multicast. So here's a CDN without multicast. Remember how this worked? Now, if we add TreeDNs, which are CDNs with multicast trees, we send first we change those CDN boxes and we call them AMT relays, and we send content from the source to those AMT relays via multicast, and from there they handle local receivers. What are the big differences? First, we can move the replication point closest to the receivers, as opposed to those boxes sitting in POPs somewhere, perhaps in the middle of the network or close to the edge. This can be pushed out to the furthest edge of a network operator's network. Also, the content only goes to relays that have interested receivers. So if you're a relay and you have no interested nearby receivers, you're not going to get this content. Also, if these relays, if you have edge routers, which are AMT capable, and this is a capability that is available in many router platforms. Essentially, and particularly, one that I'm well aware of, it's only 4 lines of config. There are no blades, no extra licenses, no extra hardware, no servers to rack and stack and plug into routers. This is an existing inline capability on existing routers. So essentially for zero CapEx, you can offer a replication service to your customers, and potentially zero OpEx because there's no cost in new power, space, bandwidth, depending on how you measure OpEx. You could argue that it's zero OpEx as well. So think of it as a CDN on a chip. So I'm here to tell you that this isn't just a wishful hope for a distant future. We've actually built this and it's available, and you can see this in action. And I'm going to send you some links where you can check it out. So the TreeDN architecture kind of has 5 steps. Well, as all great big grand plans have 5 steps. The final step being, of course, always profit. So let me go through each of these. So in terms of relays, we currently have on the internet 4 AMT public relays deployed on the M-bone being the multicast enabled part of the internet. They are at Internet 2 members who have basically turned their peering router, added those 4 lines of config, and are supporting multicast. We'd love to have more. So if any operators are interested, we've been talking to other RNE institutions in both Internet 2 and Giant, and they have expressed interest. But if there are others in the audience, we'd love to talk. And in terms of how do you discover those relays, the 4 relays, we basically use DNS. So we have 4 separate A records for a single fully qualified domain name. And we hard code the application layer with that fully well-known DNS, fully qualified domain name. And in the case of VLC, it essentially receives all four A records and goes one by one until it receives traffic. So in this way, we can get resiliency and redundancy. Not necessarily optimality, but we'll get that later. All right, so how do we watch it? You need gateway implementations. The goal and our hope was to have this available in a browser, but browsers are pretty well locked down these days. They don't even support UDP. You can't do UDP, you certainly can't do multicast. So our second best option was to do VLC. It's a distant second, but it's a solid second because VLC is open source, very multicast friendly, and it is fairly easy to use and reasonably well deployed. So we now have an AMT gateway implementation. It's been upstreamed in VLC, and you can download it and check it out. In the meantime, there's work being done led by Jake Holland at Akamai and others at both IETF and the W3C to do the things needed to get AMT, to do the things needed to get multicast supported in the browser. That's what we really need. In the meantime, VLC is good enough. All right, so if you have a relay, you have a gateway, how do you find the content that's out there? And so there's a multicast content portal. This is called the Multicast Menu. I would encourage everybody, check this thing out. It works and it's pretty cool. And it was written by a high school student, Lauren Delwich, at Thomas Jefferson High School in the US, right near Washington, DC. It was built on an earlier script that was written by William Zhang, a student who began the journey. And he was the one who deployed the first AMT relay at Thomas Jefferson High School. And it basically crawls through all the looking glasses of I2 and Giant routers to find multicast streams of a certain bandwidth, and then populates them on a web page that you could click and launch VLC to watch them. And you can manually add content. The next thing is offnet sourcing. This is where things get really interesting. So we've been talking about offnet receiving, where you have receivers who are on unicast only networks, and how do they receive multicast content? But what if the source is on a unicast only network? What if you wanted to take your smartphone and start hitting record and streaming at 4K or 8K to an arbitrarily large audience of thousands, tens of millions? So the idea is, what if we had a translator that sits at the border of the end bone, taking in a unicast only stream, turning it, translating into a multicast stream, and spitting it out into the network? And we've actually demonstrated this earlier this month at IETF. And you can check that out. So if we put it all together, here's the big I internet, mostly unicast enabled. The M bone is the multicast enabled part of it. We have a native source, native receiver. It's received the way multicast has always, we all understand it to work. Now imagine you have a receiver on a unicast only network. We deploy relays, send it natively to the relay, then tunnel it via AMT to those receivers. And imagine you have an offnet source, a source on a unicast only network. That source will send the stream via unicast to a translator who basically nats it, the destination and source address, and then it can be received both natively and offnet. All right, so what's in it for operators? Why would you want to do this? Well, it's remember the question I began. Are we approaching a point, an inflection point, where audience sizes are exploding, where bit rates are exploding for things like 4K, 8K, and VR, that we should begin to think about a new way to distribute this? This provides an ability for operators to create a viable business model for live streaming to mass audiences. The costs are a fraction of what unicast only CDNs would be. There's no new servers, no blades, nothing to rack and stack. If you have the routers that are capable of it, it takes 4 lines of config, and that's it. And all of a sudden, you can offer a new replication service to your customers. And the market for mass streaming could be huge. The last thing is, this gets us back to our roots of a decentralized internet. Is it healthy for the internet and society that pretty much all of content distribution is controlled by a handful of companies? Is that good for the world? This architecture allows networks, allows us to get back to that decentralized model of the internet. For further reading, here are the references. And I encourage folks to check it out. And if you're interested and you want to get involved in this project, and you want to join our merry band of co-conspirators, shoot me an email. We'd love to have you. We have a Slack group, and we're working on constantly improving this network. With that, I'd be happy to take any and all questions you might have.
Perfect timing there, Lenny. And you've got me convinced, especially with that argument about, IPv6 and the parallels. I'll certainly be getting in touch. Are there any people in the room that would like to ask Lenny anything else about TreeDN and AMT? Or indeed in the web chat?
I will ask one for myself.
Go for it.
So how do we... I haven't seen multicasts. I mean, I'm young, so I haven't seen multicast CDNs, multicast backbones operating with my own eyes. How well protected is multicast and the various protocols around it from things like reflection attacks? Could you accidentally subscribe your victims to a bunch of these relays and absolutely pummel them to bits?
So that's kind of an implementation question for the relays. And there are, and actually the spec does have described ways to, if you've saturated the resources of the relay, the original vision for AMT relays was they would use Anycast, and you can still use that. So imagine you're using Anycast, so that A record could map to an Anycast address on a network operator. And if the relay runs out of resources, it can just withdraw that route so that folks won't be routed to it anymore. Yes, you can, just with, as with anything, you can, send a zillion joins to relays. That's and potentially exhaust the resources. That's certainly something that implementations can block against. And that's relatively easy to protect against. In terms of the protocols, there are various ways to harden the protocols from PIM. But so the short answer is yes. And there's ways to harden things, and in terms of the implementations. And there are, specs as to, how best to harden it.
Thank you.
I should say, how's it, it's not dramatically different than Unicast, right? What if everybody subscribed to a live stream that was really popular, and you could have everybody joining a live stream? You could overrun the data plane, right? You could crash the server, you could kill the CDN. So in many ways, you could think of Multicast as DOS protection. It is preventing data plane DOS attacks, but it certainly does introduce different vectors for control plane. But by definition, Multicast is going to be much more efficient and protective of the data plane.
Okay. But surely, but surely the Threeway handshake on almost all CDNs prevents that exact thing from happening. But I'll leave it for the next question, sorry.
There is a Threeway handshake in AMT as well.
Oh, okay.
Hi, Greg Choules, ISC, formerly from a mobile operator here in the UK. I think one of the things that should be done, I don't know by whom exactly, is to try and convince the eyeball networks that they should adopt multicast internally, because then an entire network could appear to be a single client as far as the content distributors are concerned. And the reasons why the eyeball network should do this is basically, rather than their network straining to offer 2K of the big game to all of their users, their networks could operate in relative ease and offer the big game in 8K to all of their users and steal a march on the competition. So this is a very good marketing sell for why people should do this internally and make their own networks more efficient.
Yeah, and what you're actually describing is the model that Akamai has been pushing. It's kind of different than what was originally envisioned for AMT, which is basically as a last mile technology, because the thought was, the first mile supported multicast and the last mile providers don't. So, instead of trying to convince them to turn it on, let's just tunnel over them, right? So that the let's empower receivers to be able to just tunnel over any parts of the internet and access the content. But you're absolutely right. What if you're a last hop provider, last mile provider, and Akamai is actually doing that, and there's a thing called Dryad that Jake Holland is a big proponent of, and it does exactly what you're saying, which is imagine the last mile is multicast enabled, and you need to tunnel it back to the first mile. Because between the last mile provider and the CDN provider is Unicast only. So you can use AMT as a bridge there. So that's another model that certainly works. And Jake has spoken a lot about this at IETF. I would encourage you to take a look. He's also spoken at NANOG, Packet Pushers. He's had some very promising trials and lots of great experience. So that certainly is a great model as well.
Thank you.
We've got time for one more question, I think.
Hi, Lenny. Hi, everyone. I'm Mike Hughes. I work for CDN. I'm one of those BFU guys. I've got a couple of questions. I'll also start with a pointer. I was at the Links meeting last week, and Richard Cooper from the BBC was talking about their latest experiences in UHD. The bit rates are coming down now. So you were saying 40 gig, which is 40 meg for a HD stream, very much on the top side now, and they're coming down to sub 30 meg now for a good quality UHD stream with a full color gamut. So I think when you multiply that by your Super Bowl reference, you actually lose about 150 gig per second, 150 T per second of what you're delivering. So it's quite significant. If you drop down below 30 gig with the better encodings. The other question I've got is twofold, but go ahead. Yeah, sure.
I would say, remember, that's the high water mark is what matters, right? So even if your average bandwidth is less than 30, still that's first of all, 30 is a lot. Especially when you have millions of viewers, right? And And just think of the cost. 30 times a big number is a really, really big number. Whereas, whereas if it's with multicast, that number, that marginal cost is zero. It's constant whether you have 1 million viewers or two viewers. So, but yeah, high water mark is also important to remember. It's not just necessarily average bit rate.
I just wondered if you've been keeping up with that, because that was certainly what they're seeing now as high watermark for some newer TVs. So what they said was they hadn't done any UHD for sort of 2 years. And then having come back and done the sporting events this year that were restarting, what they found was newer TVs had a much better codecs, and also the codecs had developed. So they've found the performance, even in the space of 2 years, it improved significantly and was reducing the overall bandwidth demands for UHD. Second question, and has there been any work done? You're allowed to say, hey, that's above layer 4, I can't answer that, that's fine. But has there been any work done in terms of multicast distribution with respect to implementing DRM and also implementing copyright protection such as watermarking? Because obviously if you talk to the content owners, particularly for non-free-to-air content, watermarking is really big, particularly for the high value content like sports.
Right. To answer your first question, have I been tracking bit rates? And the answer is no. I'm a network guy, so video is a black art to me. But whether it's the numbers I got were just Google. I Googled what is the bit rate of 4K, and those are the numbers you get when those are the first entries. So. It doesn't surprise me that there might be better codecs, and they're improving and bit rates are going down. But even if it's 20 meg, it's still a big number, right? 20 meg times 15 million is 300 meg instead of 600. 300 terabits instead of 600 terabits. That's still an awful lot of terabits, right? And don't forget there's 8K. Don't forget there's VR, and it just goes up from there. And audience sizes are going to go up from there. In terms of DRM and access. The short answer is whatever you do in Unicast, you can do in Multicast. UMetSat is a great example. They are encrypting their streams, and they use offline methods to distribute the decryption keys. There's no reason why that couldn't be done as well. I'm not a DRM expert, but generally I have a one-word answer for any access control and DRM question, and it is encryption. And you can do encryption with Multicast just as easily as you can do it with Unicast. And UMetSat is a great example of that. And they're doing multi-factor authentication. They're doing some really interesting stuff with protecting their streams, access streams.
Okay, thank you.
Sure. I appreciate everybody's time, and again, if anybody's interested, please reach out to me if you want to get involved in this. We'd love to have more folks working on it with us.
Thank you very much, Lenny. That was a fascinating and really fun talk.
Great, thank you.
Cheers.